Do you hear me? Do you hear me? Great. Great. At first, what is rigid object? Rigid object, for example, a wheel that can translate and rotate. Now we will learn about what are the dynamical equations we should use to describe the motion of a rigid object. Few things that for a rigid object the acceleration is not that straightforward, because even if you rotate something with a constant v, no, it's all right, you can't see acceleration, but there is always a so-called centripetal acceleration, this radial acceleration. If you also increase the rotation of the system, that means you have this alpha angular acceleration that causes the tangential acceleration. So radial is omega square r, or v square over r. That comes from the fact that this is rotation and there is acceleration even the v is constant, the speed is constant. And if you speed up the rotation, if we have a tangential acceleration, the sum will be the net acceleration of the body. Instead of only 1 over 2 mv square, which is true for the kinetic energy of the translation, we have to introduce the moments of inertia to describe the rotational kinetic energy as easy as it was in the translation. This is 1 over 2 something about the body, not only the mass but also the shape, and the omega square, which describe the motion of the particle. Calculating the moments of inertia is not easy, but we can learn for some mathematical object like cylinder, balls, a piece of plate or something. You can calculate the moment of inertia, it's easy. What about torque? To describe the motion of the rigid body, the Newtonian second law is not enough, because that describes only the translation. For describing the rotation, we have to introduce this torque, and the torque is nothing else than the R cross F. You can see here. If this is a simplified motion, like we rotate something in the plane of your screen and not a complex motion in 3D, so if we stays in the 2D, or we can simplify your system like a 2D motion, this is one we can calculate easily. We have to fix the origin into the axis of the rotation, and then if the force acts here, this is the point of the action, and the force vector is this force, we have to calculate this R cross F. Do you remember how to calculate the cross product? R is the A, B is the force, and the cross product goes that direction. Can you tell me, and please write your answer in the Discord, what is the direction of this torque vector? Look at it, memorize the order of the fingers. Or, by the way, I sent you the link of the presentation. If you go back to that slide, perhaps it's easier. Tell me what is the direction of this torque. I wait 1 minute. Upwards, yes. So go back here, R, G, force, R, force, that will point from the screen to the direction of your face. So if you look at it on your phone and it lies on the table, it's upwards. All right. So what quantity we can use to simplify this vectorial, this cross product? We can calculate the so-called line of action, which is nothing else, just extend the vector with this dashed line. And this d, the level arm, is the distance between origin and this line. So the torque, if we are in 2D and do not worry about 3D problems, is the force times level arm, which is the force times the length of this r vector times sinus theta. Oh no, it's phi. So how can we describe the rotation? What are the equations? Parallel to the net force equal m times a, its net torque equal moments of inertia times acceleration. These are pretty simple. How can we calculate the sum of the torque? Let's see an example. This is the seesaw. Go to a playground and find one and put mass 1 on the left and mass 2 on the right. What are the conditions for the balance? Just a second. All right. What can we learn? What is sum of the tau? Let's choose the axis of the rotation as origin, as in the previous example. And here we have a weight 1. Here we have a weight 2. This is the coordinate of the point of the force. In this case, can you tell me what is the direction of tau 1, which is R1 cross G1? So look at the picture of the right hand. It will again upwards if your screen lies on your table. Okay, thanks. So this is the direction of tau 1. The tau 2 goes in the opposite direction. So what we can do, let's choose a positive direction, which is the upwards. And what is the condition for the balance? The sum of the tau means tau 1 with plus sign minus tau 2, and this the balance means the alpha is 0. So that means the tau 1 has to equal to tau 2. And if let's I clear the table, but we can download from the screenshot from this smart card. Oh, that was 10 kilogram, 15 kilogram. Just a minute. Sorry, I'm back. So what is the uh, this is a rigid body. This is of course a system which contains a massless seesaw and two masses. Here we have 100 Newton as weight. Here we have 150 Newton. And this R1 is 2 meter. And the question is R2. How can we calculate it? At first, let's talk about translation. For translation, the sum F equal m times A is the basic equation. What it means? Let's sum the forces. If you sum, of course, let's choose again a positive direction. The sum of the forces is G1 plus G2 equal m times A. This is 250 Newton equal 25 times A. The A is 10. What's wrong with this calculation? Since for balance, A and alpha has to be 0. What did I miss to get this free fall acceleration? Can you find out how can we this seesaw balanced in translation also? What force I missed? Yes, exactly. Like if you put a box on your table, the box has a weight and there is a so-called reaction force that compensate this G and can fulfill the A equals 0 condition, which is technically the sum of the F equals 0. So here we also have to say, but you can measure it, a reaction force and look, the positive direction is downward, so that will be minus R equal m times 0. So G1 plus G2 equal R. So this R has to be 250 Newton. 250 Newton upwards. Let's see what is the condition for the balance in rotation. So the dynamical equation for rotation is sum of the torque equal moments of inertia times alpha, but balanced mean it has to be 0, so sum of the rotation has to be 0. What is the sum of the rotation? Right now we are pretty lucky because the angle between force and this R is 90, so we can forget this sinus alpha. So what is the tau 1? Torque 1 is 2 meter times 100 Newton. This is 200 Newton. And the torque 2 is R2 times 150 Newton, which is still unknown. What about directions? So the left weight causes a torque towards to you, so upwards, and the other is in opposite direction. So tau 1 is plus, minus tau 2 has to be 0. That means R2 times 150 equal 200, R2 equal 1.3 meter. All right, let's solve. I will ask you to solve another example. Here I have a massless seesaw, a very long one. I put 100 kilogram here at 4 meter. What mass should I put here at 5 meter to be balanced? And I want to know the mass too, and also this reaction force. I can give you, let's say, 5 minutes. So this is mass 2. It was not that nice. Mass 2. Send the result in 3 minutes and not before, to stop the others to solve it in the Discord. All right, can you send me the results? Yes. And R is? And the reaction force? In the last example, we said the sum of the torque, I'm still waiting for the reaction force, sum of the torque is tau1 equal tau2, plus tau2, but one is positive, the other is minus direction. What about the torque from this reaction force? Why can we forget the torque from the reaction force? Why is it zero always? Look at this picture. Here we have a force and there is a level arm. And the torque is force times level arm. What if one force goes through the axis of the rotation, like just moving this this F vector here? What if the force goes through the axis of the rotation, like in this example? Axis of the rotation and this force is exactly go through this axis of the rotation. What does it mean? That means the level arm is zero. So therefore, the torque from this reaction force is always zero, so we can forget it. All right, that was a simple example. I think you will be able to solve it. Let's look at this example. Oh no, the previous one. This is also a rigid body, can translate and can rotate. This is a wheel or cylinder. You will pull this cylinder with the force that goes through the axis of the rotation. There is mass, radius, and friction, and since there is friction, there is force of friction also. Let's use the T here. Let's add the equation for the motion. The one for translation is sum of the F is m times a, sum of the torque is capital I times alpha. Pure rotation means, wow, pure rolling means this is a pure rotation. You can imagine this pure rotation like fixing this wheel and just rotate. Pure translation is just moving this wheel. The pure rolling means you add one pure translation with the V that equals to omega times r. This is the pure rolling, is how the wheel moves, how the wheel of the car or the bicycle moves on a dry road. It rotates, and according to the rotation, it will translate. What is non-pure rolling? When you try to move a wheel on an icy road, it can, for example, only rotate, but the car does not translate, the wheel won't translate. So pure rotation, we can use this formula. So pure rotation means V equal R times omega, and the acceleration equal R times alpha. So this is technically the condition for pure rotation. It's nothing special, it's just how the wheel of your bicycle moves on a dry road. All right. What do we need for pure rotation? Let's go back once again for this picture. The pure rolling means the center of the wheel moves with a V. This lower part of the wheel where it touches the road, that does not move, so it's fixed. Not forever, but only for the second when it touches the road, and then since this point moves around the circle, the point changes, but its position is fixed. For that, if it's fixed, that's a static friction. Static friction means another condition. It's true only if the force is smaller than the perpendicular force. In this case, this is the weight. So, how can we solve it? Let's assume this is a pure rolling. Wow, my handwriting is not that nice. That means three equations. Sum of the F equal m times a, sum of the torque equal I times alpha, and the pure rolling, let's use this one, a equal r times alpha. So these are the three equations we have to solve. I clear this table, but you can download it. It's in the snapshots, so anytime you can come back. Wow, can I leave it? Yes. So what we have, a wheel, we pull it, mass m, radius r, mu, and t. Sum of the F equal m times a, sum of the torque equal I times alpha, and a equal r times alpha, and pure rolling can be expressed that the t smaller equal than mu times the weight. Let's solve it by assuming that this is a pure rolling. Sum of the F is F minus T equal m times a. This is a plus direction, the right is the plus direction, the force goes to the right, and the static friction tries to stop it, it will have a negative sign. What is the force that can rotate the system, that can create any torque? Since the force goes through the origin, the axis of the rotation, like in the seesaw example, that won't rotate. Only the friction rotate by the level arm R, since this direction, the origin and the action point of the friction is R. The moment of inertia for a cylinder is 1 over 2mr square, and here we have an extra alpha. A equal R times alpha. Let's use numbers like this one. That means 450 minus t equal 100 times A. T, still t unknown. We only know that the pure rolling is true if the t is more equal than mu times g. So this is very similar to the incline and mass. At the beginning, we have to suppose something, that it's fixed, and if it's not true, we have to come back. So this is 1 over 200 times 1 square times alpha, which is 50 alpha. But from here we know A equal 1 times alpha. Don't forget the A has a unit meter per second square, and alpha has 1 over second square. This is not a unit, this is a 1 meter. So if the monomial value is alpha is A, we can write here 50A. Let's go further with this equation. 150 minus 50A. Let's replace the t with 50A equal 100A. Just a second. All right. So 450 equal 150A. A will be 3 meter per s square. There was 3 equations, 3 unknown, we can solve it. But it's not solved because we suppose that this is a pure rolling. We have to check the condition for the pure rolling. Let's use this one. So t equal 50A. So t equal 150 Newton, since A is 3. 3 times 50 is 150. Is it smaller or equal than mu times g? So this is a body with 100 kilogram. The weight is 1000 Newton. The mu equals 0.6. And that's 600 Newton. Is it true that 150 Newton smaller than 600 Newton? Yes. So we can say that this is a pure rolling. In other words, wow, I missed some part of the equation. So in other words, the friction is enough to move this body without slipping. And now try to solve it. I forgot to save it, sorry. Try to solve it with R equals 0.5, M equal 50 kilogram, F equal 100 Newton, and mu equals 0.4. The question, pure rolling or not? If yes, what is the T, what is the A, what is the alpha? I can give you 10 minutes. And just download my presentation. You can use the basics, so the equations, and also the way how I solve this one. Both can help you. 10 minutes. All right, let's solve it together. I do not draw it again, so you can see the drawing on that plot. So 100 minus t equal 50 times a. Equation 1. T times 0.5 equal 1 over 2 50 times 0.5 square times alpha. These are the dynamic equations for translation and rotation. Nice, even better and better, but what is the mu? Mu is the constant of the friction. You remember for the incline example, this is what we had to check whether it's large enough to stop the body. So this is the dynamical equation, and the condition for pure rotation equal A equal 0.5 times alpha. Let's start with the second one. 0. Oh, sorry. 0.5, 0.5. So here we have 25, 12.5. T equal 12.5 alpha. A over 12.5 equal alpha from this one. So this is T equal 6.75 times A. Let's go back with this T here. Let me double check myself. 12.5. Yes. So 100 minus 6.75 A equal 50 times A. 100 equal 56.75 point A. Divided 56.75, or in my case A will be 1.76 meter per s square, alpha equal 3.52, no 3.5, no 52, 1 over s square, and t equal, no, I think I missed something. Do you see where I missed it? No. A is the half of the alpha. Let's see. T is, no, I had two different values from T. Just a minute, I correct myself. I found alpha equals 0.881 over s square. So 6.75 times 1.76 times 6.75. This is about 12 Newton. Can it be smaller equal than mu times the weight, which is 500? That's 200. That's definitely smaller than the maximum value of static friction. Let me double check. Perhaps you're right because you got the same result several cases. Let's have a break here because I missed it, so I will write the right solution. Let's meet in 15 minutes. All right, I missed here. Dividing with 0.5 is not multiplying with 0.5. So alpha equal 2.666 1 over s squared, and t will be 25 times 1.33, which is 33 Newton, but it's still 33 smaller equal than 200 Newton. So this is a pure rolling. So thanks for your patience. All right. Now let's go to the example when, look at it, I've only changed this mu to 0.1. When the friction seems to be not that high, so that's an icy road situation. If you pull this force, with this cylinder with the same force, that can cause problem. Let's check it. So again, the dynamic equation for translation is F minus T has to be m times A. Rotation, only the friction rotates with 1 over with level arm r, mr squared times alpha. And if you assume this is a pure rolling, we can use this r, a equal r times alpha. The t, any t what we will get, has to be smaller or equal than mu times weight, and in this case this is only 100 Newton. So if we solve it like we solved before, you will see you will get a t equal 150 Newton, which is not smaller equal than 100 Newton. So the static force can't be large enough to guarantee the pure rolling. It's not pure rolling. What can we do? We can forget this condition a equal r times alpha, because that's only true for pure rolling. That's only pure for the how the wheel moves on a dry road. If it's not true, the other two has to be true, because these are the so-called Newtonian equation for translation and rotation. But if it's not a pure rolling, we can forget the static friction, and that will be the kinetic friction. And the kinetic friction is easy because it's equal to mu times weight, which is in this case 100 Newton. So we lose one equation, but we also lose one unknown, because right now t is not unknown. For kinetic friction, we know that this is 100 Newton. And let's say the example on the slide, 450 minus 100 equal 100 times A. We can calculate directly the translational acceleration, and also 100 times 1 equal 1 over 2, 100 times 1 squared times alpha, which is alpha equal to 1 over s squared. And that's all. So if it's not a static friction, if it's a kinetic friction, you don't have three equations, only two, and you don't have to manage this equation, because every equation can answer one question. So from the Newton second law for translation, you can answer the acceleration, and rotational form of the Newton equation can answer the angular acceleration. All right. I hope you still remember how to calculate, how to integrate the acceleration to have the displacement vector, because if we look at the center of this wheel, oops, let's choose a coordinate system. This is the x-axis in meter, this is the origin, and for example this is 1 meter. If we look at only the origin of this wheel, if you calculate an A, like 3.5 meter per square, if you know the initial position, initial velocity, if initial velocity is 0, initial position is 0, the xt of this body will be a over 2t square, which is 1.75 t square. So if I ask where is the body at 10 seconds, that will be at 175 meter. Also pretty easy to calculate what is the angular displacement. For that we also need boundary condition. So for example, this straight line represents the theta equals 0, and if the initial omega is 0, this will rotate, and if you look at one point of this wheel, it will change its angular position. How will it change the angular position? If theta t equals 0 is 0, like here, if omega t equals 0 is 0, this is alpha over 2t square, that will be t square. So for example, t equals 10 seconds, it will be 100. This is in radian. Of course, it's not too easy to say where is the 100 radian. So let's divide the 100 into n times 2 pi plus some residual. Let me calculate it. If you divide 100 with 114, so that will be 15 full rotation, because 15 full rotation is 95.25. The rest is 5.7, but we should express it by pi. So this is about 1.83 pi, which means if I start here, so let me show you, if the theta zero is here, so this is the pi, and this is, let's say, 1.8 pi. So if you pick up this point, now I'm talking about this point, the original point where it touches the surface, at the end, so after 175, this point will be somewhere here, after 15 full rotation. All right, let's solve another one. And you remember, I do not have to add these EECE boundary condition like xt equals 0 is 0, v xt equals 0 is 0, and so on and so on. I can add anything, but I think you can solve both. Force, radius, friction, mu. These are the things we have to worry about. And let's say m equal 20 kilogram, let's say r equal 1 meter. It's a big white cylinder. F equal, well, 100 Newton, and mu equals 0.3. The question is it a pure rolling or not? The mu is pretty small, so my feeling is this is a non-pure rolling, but we have to prove it. So you should write the equation for dynamics, the condition for pure rolling, solve it, and if the static friction what you got, is really a static friction like smaller or equal than mu times weight, then we are okay. If not, that will be a non-pure rolling. Start to solve it, please. Yes, it's 20 kilogram. All right, it's a good news. So 100 Newton times the unknown T has to accelerate the body. The T will rotate via level arm 1. It's a cylinder 1 over 2 20 times 1 square times alpha, and for pure rotation A equal R times alpha. That means the nominal value, what we wrote here, this 3.3, is the same point for alpha and A, but don't forget the units are different. Let's solve it. So from this one, T equal, it's 10 alpha, adding this one, 10A, 100 minus 10A equal 20A, 100 equal 30A, A equal 3.3 meter per square, alpha equal 3.3, 1 over a square, T equal 33.3 Newton. And let's check it. Is it smaller or equal than 0.3 times 200, which is 60? Yes, so that was a pure rolling. The ones they can solve it, I think, ready for the test too, because it will be seesaw and pure rolling. So we will pull this. I will add this example with different numbers. I've seen some active students here. What about the others? So the others, were you able to solve it? Or, or should we go back to some very basic previous step where you missed it? So please help me, because we can solve 10 other pure rolling situation, but that will be perhaps boring for the ones they can solve it, and uh, perhaps it won't help you. It won't help you. Write something what where you stopped, or just say that I can solve it. I just was not ready to share the information in Discord. You mean the seesaw? No, everything means only the rotation. Seesaw plus pure rolling. That's all. No, we won't go back to the test one. Only rotation. Yes, and only calculation. So in the test too, if you can come to the university, if you can write a separate test 2, that's only calculation. 2 questions, CISO plus pure rolling. That's for test 2. If you can't come in, but during the exam season, if you can come in, even with limited numbers, I will add these 2 questions for the exam. And of course, we have to talk about students. They don't have the test 1 because that can cause problem, but how we know the F react? All right. CISO, axis of the rotation, let's say a mass 1 which is 10 kilogram and a mass 2 which is 25, and we place it at 5 meter. It's a very long seesaw. In person, it's a written. The test is in a lecture hall because I like to see you how to solve it alone, and you should come. I hope this virus situation won't be worse and you can come here. We have a big lecture hall here, the ones you were, or there's even a bigger one with 120 seats. When is yes, this is a question when if you can come in the last week of the semester, you can write it. You can also write it in the first week of the exam season. But if you can't come in, you will write the test to in the same time of the exam. Technically, that will be a theory plus practice for the exam. Yes, but for registered exam, so uh, let's wait a few days or week. If the university will be open after 10th of December, yes, you can't register for the exam because you don't have grade or signature for seminar. Yes, right now you can't come to the university till 10th of December. It will be announced whether you can come. If you can come, you will write the test too at, for example, 11th of December or 14th of December, very close uh, to the end of the semester. But since we don't have test 2, I can't add you grade for the seminar and you can't register for the exam. If it will be announced soon that university will be closed till February, I will add the grade to you based on the test 1 and you can register for the exam, and I'm also okay to have an online exam if it's a must. But let's wait for any announcement. What is the virus situation? How can you move? How can you come? There are other seminars when you have to write a test, so it's not only our problem. Uh, it's wait, I copy my answer from somewhere. Just a minute. Oh. Right now, the university is closed till 10th of December. No, you registered for the exam. That's the exam. All right, give me a second to summarize everything in Discord. Is it clear what I said? So everything depends on any announcement, whether right now the university is closed only till 10th of December. That's the fixed. Extend it or not, I don't know. Exam if a must, of course. Right now we had only a test one, which based on the some translation. You didn't show me what do you know about theory or Newton exams or coordinate system. These are simple, but once you have to also say something about the theory, that's the time for the exam. And in the case the test turns to online, the test date will be the same. I hope so. Normally, if the test 2 won't be, I will give you a list of questions like, for example, Newton theory, what is a coordinate system, work theory, and such a physics things. Formulas, yes. So, what is the formula for kinetic energy? What does it mean, work? So, what I said several times, work is energy transfer. Energy must be conserved in a closed system. The work of inner force is always zero. So, like these. Yes, I think. I mean, no. I mean, normally, yes, only from PDF. Yes, so normally every changes in this virus situation is announced at least 1 week before. So I think we will know much more in the next week. Hope so. You can feel how flexible and strange is this situation. Let's go back. Who knows what is the R2? Where should I put this box to be balanced? And what is this reaction force that goes through the axis of the rotation of the seesaw, the supporting system? The left box is 10 kilogram, the right box is 25 kilogram. The left box is placed from the origin at 5 meter, and the right box is placed at R2. You should calculate the R2. And also the reaction force, the force that goes upwards uh, and compensate the weight of the two masses. Thanks, that's correct. Oh, I absolutely forget that I've written it. Oh, yes. Thanks, Esther. Of course, right now it's not too easy to rewrite any of the tests since you can't come in, but otherwise it's true. All right. And this is a rigid body. So what we need to know is nothing else that the sum of the forces equal m times a and sum of the torque equal I times alpha. And the balanced means no acceleration and no angular acceleration. How can we guarantee that a is 0? For a is 0, the sum of the F has to be 0, and for alpha is 0, the sum of the torque has to be 0. What is the sum of the forces? We have 100 Newton here, 250 Newton here. The sum of the force is still 350, so we need a 350 Newton upwards to compensate the downwards 100 plus 250. That was easy. The torque, for the torque we have to know what is the formula for torque. In this situation, since the angle between the uh, position vector and the force is 90, torque 1, and let's choose a positive direction which is upwards, torque 1 is plus 5 times 100. This is torque 1, and torque 2, and torque 2 is minus 200 times R2, because we don't know what is R2. This is a question. The sum and the torque from the reaction force, this is very important, this is 0 since it goes through the axis of the rotation. Torque plus torque 1 minus torque 2 equals 0. This means 500 equal 250 R2 divided by 250. R2 has to be 2 meter. So the capital R, the reaction force, is 350 Newton, and the R2, where should I position the box to be the seesaw imbalanced? This is 2 meter. Yes, me too is also complicate things. Uh, but if you go to my slides, it's here, but not with numbers, but with formulas. So at first, should we serve any other examples? What do you feel? For next time, please go through all the PDF and we will find some good questions for the theories. I won't add you very trivial, too easy questions, but as also I won't load you with very complex one. Just go through it to have some feeling what we learned in this semester, and we can set up a list of, yes, so for you, the ones they wasn't able to write the first test, I can't say anything else, just be patient. If this is the option 3 and we won't meet only in next February, you will write it online. If you can come to university, the ones they don't have the test when, they will also write it with the test too in the same time. Further questions? Can we say goodbye? Or the ones they want to ask something can stay, the others can leave now. I'm still waiting here. Yes, but uh, wait a bit. So I think it's here. Of course, it's still running, so it's live, but after I close it, it will be saved and you can check it again. So by the way, I can stop the streaming